Tobenna Arodiogbu is the CEO of Scotty Labs. And what's really interesting about what they're doing is you hear a lot about autonomous driving, and there's sort of 5 levels, right? And the 5th level is just the car does everything on its own. And there's a lot of people that believe that level 5 autonomy is going to be a lot harder than you think. And so Tobenna is one of the people that's working on some business models that might take that assumption into play. So he's going to talk a little bit about autonomous AI and the tolerable error rate.
Hello. So my name is Tobenna. I'm the CEO of a company called Scotty Labs. I'll talk a little bit about what we're doing at Scotty and then something that we've been thinking about a lot over the past 2 years. So Scotty is building an autonomous trucking solution. We really wanted to focus on the trucking industry, but like Rob said, we're not really believers in this idea of getting the driver out of the truck as soon as possible. We believe that there are a bunch of steps that we need to take before we get there. We believe in having some combination of autonomy and teleoperation. So that's really what we focused on over the past 2 years. Little bit about me. So I come from a product background. Prior to founding Scotty, I'd worked at Zenefits as a product manager while that company was scaling. Worked at Open Door, where we were buying and selling real estate online. And then I worked at SRI. So SRI is this large research institution. That's where Siri was founded. And they've done a lot of work in autonomy and teleoperation over the years. So it was really a good experience working with that team to found Scotty. So we spun Scotty out of SRI. And this is a day in the life at Scotty. So this is us testing our truck. So right now we do a lot of testing in private roads, getting ready to start testing on public roads. This was a 55 mile per hour test at a runway in Alameda. So we do this over and over again, testing highway-like scenarios, staying within a lane, switching lanes, putting other vehicles in front of our truck, making sure that it's safe, things like that. This was taken a few months ago. So as you can imagine, this is a full tractor, right? 18-wheeler truck with a trailer attached to it. So we can't really make mistakes when we're doing these tests. We definitely can't make mistakes when we take this out to public roads. So we try to be very careful about this. And that's what led me to this talk, right? I was thinking about different problems that AI companies have to go through and what different types of AI problems are out there. And I've gotten to experience some different types of problems, so I wanted to talk about that a little bit. So first of all, intolerable error rate, right? So as I was saying earlier, working on a truck, we can't really make mistakes. We have to have this, we always have to think about how much testing is enough. How accurate does our entire system need to be before we say that this is actually enough to deploy a product? That's a big problem in the autonomous driving space. Do you need perfection? Do you need something that's closer to a human driver which still makes mistakes? Things like that. How much data is enough? How many scenarios do you really need to test before you say that things are sufficient, right? And the other thing is tolerable response time. So I think this is something that isn't talked about quite as much. So after working in a number of startups in the Bay Area, I found that one of the unique advantages of a startup is having the ability to cheat, so to speak. So the point is, you want to have as little cost as possible to release a first product, and then you want to learn whether things work or don't work, right? Now, in the case of building an autonomous vehicle, the tolerable response time is sub 100 milliseconds. So you capture data from your sensors, and then you need to give some type of output in less than 100 milliseconds, which means that you can't really have a human in between this loop kind of helping the system make decisions, right? So that's what we mean by tolerable response time. This means that there are no shortcuts. We need to have a really, really good product before we actually go out there on public roads. And for us, what that means is we go through this cycle of development. So we build some stuff, and then we test it in simulation. We work with a bunch of simulation partners. Then we test it in private roads, and then we test it in public roads, and then we continue this full loop, right? And we just do this over years. We've been doing this for the past 2 years now, and we're continuing to do it over the next few years. We don't actually know exactly when we're going to deploy. But the other side of this for us is rather than thinking about ways to, increase the acceptable error rate for us or increase the response time, we just kind of narrow the operational design domain of the product. So we're not trying to build something that works everywhere. Like I said earlier, we're not trying to build something that takes the truck driver out of the truck. We have a very specific problem that we want to tackle first, which is how do we extend driver hours of service? How do we increase the comfort for the driver? How do we increase the safety for the driver? And then we continue to go from there. So this means that we limit to very specific roads, very specific highways. We don't do any testing at nighttime. We feel like if the driver is there in the truck, they can drive at night. We can focus on daytime driving. We don't try to do anything in snowy weather, things like that, right? So just limiting the scope as much as possible. Now, this is the part of all of this that a lot of people don't really talk about is if you're building a product, especially an AI product that has a low tolerable error rate and a low tolerable response time, it means that you need a lot of capital, right? So this is why you see a lot of autonomous driving companies raising billions of dollars because, just the bar is really, really, really high. So my point on this is all AI problems are not created equal. I think there are different founders here, and this is something that I think about a lot today. I wish I thought about more earlier. So it's something to just think about as you're thinking about a product that you want to build in this space. So I think this is a question that every AI startup needs to ask themselves. In addition to the questions around are you solving a real problem? Is this something that people actually need out there in the world? You have to ask yourself, what are your tolerable error rate? What's your tolerable response time? And this is the other way of asking the questions. How perfect does your V1 really need to be before you get out there? And the second question is, how much can you cheat? So to what extent can you have humans in the loop? So to give examples of this, by the way, so I was asking my team what type of examples I should give to the audience, right? And the first example of a company, I actually don't know if I have the slide here. Okay, I don't. The first example of a product that has high tolerable error rate but a low tolerable response time is like Uber Eats. So when you order some food, they give you some window of when this food is going to be delivered. You don't care that much how accurate this is. It could be off by 30 minutes or so. So this allows them to actually release a product sooner, refine it over time. The second example of a company that has the opposite, right? So low tolerable error rate and high tolerable response time is a company like Opendoor, right? So Opendoor is buying and selling homes online. They have relatively low margins. They can't make mistakes on the prices of these homes where they're trying to automate the offers that they send out to people. So now the hack that a company like that could have is to release an initial product. They could have a human check the price before it actually gets sent out. And then over time, this gets better and better and better, and they can automate it. So this definitely reduces the cost. So increasing, having a high tolerable error rate or high tolerable response time decreases the cost of developing a product. The lower and lower these things are, the more expensive it is to build a product in the space. And that is all I have. Thank you.
I really like your approach of augmenting humans rather than replacing them. I really think that most of the autonomous driving companies are really aggressive on just automating everything. Could you elaborate on a little bit more and how you plan on getting out of this crowd, basically?
Yeah, definitely. I like to think of this in terms of what's a really good research project and what's a really good product, right? And like a good research project is definitely solving full like L4, L5 autonomy, whatever you want to call it. I think a really good product in specific industries is augmenting humans, right? So in the trucking industry, there are very specific dynamics at play. So you have a maximum of 11 hours that a driver can drive in a 24-hour period. The very first thing that drivers actually care about is, can you help them expand this, or can you help them, can you give them more comfort while they're driving, and things like that, right? There's a monetary value to this also. So every single mile that a truck moves for, they're making somewhere in the $2.10 to $2.80 range. So provided that you can give them more and more and more miles, there's actually a dollar element to this as well. And most industries think that way, is right. Like, it's, are you increasing my top line? Are you decreasing the cost that I have as a business? So for us, really, what we've done is we've spent a lot of time with trucking companies. We think a lot about what is a tractable solution to get our solution on different vehicles out there. We have the teleoperations components more as tier 1 support, so we don't directly control the vehicle. We can send waypoints and send guides to the vehicle to follow, so we think of that as tier 1 support as well. And it's all about just increasing efficiency for the trucking companies. Yeah. Yeah, so, yeah.
Can you repeat the question for the audience?
Oh, yes. So the question was, can we overcome the legal barriers to extend the hours of service? So there are a few points here. So the short answer is yes, but it depends on how you think about it. In trucking, there's 11 hours of driving, but there's actually 14 hours of operating. And right now, operating is a fuzzy term. It could be anything from filling up gas or loading and unloading the truck or anything else, really. So our belief, and based on the legal work we've done so far, is that if you have the autonomy actually driving for some period of time, that could be considered operating. So that's the first way to do it. There are also different, basically different groups at play in trucking. So there's associations like ATA who represent really large trucking companies. There's associations like OIDA who represents owner-operators. Most of the industry is owner-operators. When you talk about replacing the driver, ATA gets excited. OIDA hates it. When you talk about augmenting the driver and increasing hours of service, both of them actually like it. So for us, it's working really closely with those groups and working with the trucking companies and working within the confines of the legal barriers that exist today, and then moving forward from there. Yeah.
Is your plan to be a backup to self-driving cars when it's level 5, or is it to get us to level 5 and be like the intermediate step between, my Tesla's autopilot and eventual level 5, so that when you have somebody in the level 4 car, they feel a little bit more comfortable?
Yeah, so our plan is to get to that level 5 whenever it happens. I'm a bit pessimistic on when it happens, but whenever it happens. So right now our goal is to get the technology out, get it on actual trucks within the next few years, and then that allows us to build up more and more data, more and more experience, and expand from there.
And what will the experience be like for a truck driver? There'll be a truck driver going across country. Yep. They need to take a nap, and somebody in a remote location takes over and drives 8 cars at once, like a poker player multi-tabling?
No.
Because you had telematics as part of your solution, correct?
Kind of. So basically, there's a truck driver going down the highway. At some point, they get a prompt that says, Scotty can take over now on this highway stretch. They push a button, we take over. So we have an autonomy solution and a teleoperations backup. So we take over. In the initial product, the truck driver doesn't go to the back or anything like that. They're still physically present, but we are in control of the vehicle. Over time, then we want to get to the point where the truck driver can go to the back, and then at some points...
What is the truck driver expected to do when Scotty takes over on that long stretch of deserted highway.
Very similar to what they do today with Tesla Autopilot.
So they're supposed to pretend that they're driving the car, put their hands on the wheel and pay attention.
Hands on the wheel, pay attention. We'll have an inward-facing camera actually monitoring them as well.
So it's almost exactly the same experience for them as driving, except they're not in control.
Yes.
The criticism of this from Google has been, as you well know, that humans are fallible and will play Candy Crush or text.
Yep.
Is that a fair criticism, part one? And part two, Elon said he'll have a robo-taxi fleet on the road by the end of next year. What is the percentage likelihood that he will, in your mind?
So on the first question, I think it depends on what exactly you say the product is and what the product does, and to what extent do you monitor the driver as well, and do you use maps or don't use maps and things like that, right? So like I said earlier, our goal is more to augment the driver. I think if you're actually monitoring the driver, one, you're using maps, two, you're using more sensors, three, you start to cover more and more and more of the issues that maybe Tesla is having today. And having the driver seated there is more like a regulatory compliance type of thing. We're only going to release on stretches of road that we're actually very comfortable driving on. On the second point, it's not going to happen this year.
Well, he said end of next year. What do you think the percentage chance, if you were to place a bet, what would you feel comfortable with on a percentage basis that there'll be robo-taxis?
Yeah.
Forget about from Tesla, anybody.
Yeah.
Anybody has robo-taxis on the road by December 31st, 2020.
Oh, so that there will be robo-taxis on the road 100%.
Without steering wheels, without drivers.
Without steering wheels.
Level 5.
Yeah. I'll put that close to 0.
Got it.
And with some driver who's like still going to take over, I'll put that, that's closer to 100%.
Yeah.
Yeah.
Okay, well done. Big round of applause.